There's a moment in historical research when a pattern starts to appear, not in grand battles or sweeping migrations, but in the everyday choices people made to survive. When you start reading old farming accounts, frontier journals, Scandinavian winter logs, and early settler manuals, one material keeps showing up again and again: ash. Not in the casual, careless way we treat it today, but with a kind of reverence reserved for tools that consistently kept people alive. And here's the strange part. The people who understood ash the best, the charcoal burners, the slash-and-burn farmers, the Nordic homesteaders living half the year in snow, did not behave as though soil pH was something worth worrying about. They didn't measure acidity. They didn't correct numbers. They worked from an entirely different philosophy of soil health, one so effective that it calls into question whether the modern obsession with pH is even the right conversation. This first minute matters because once you understand their method, you may never look at your soil the same way again. The idea that soil pH dictates everything, what lives, what dies, what yields, what fails, dominates modern gardening guides. If your soil is acidic, you're told to add lime. If it's alkaline, you're told to add sulfur. Then you wait for the adjustments to slowly take effect, hoping you didn't overshoot. But the ash masters of the past approached fertility from another angle entirely. They saw soil not as a chemical equation, but as a mineral system. To them, the issue wasn't acidity, it was imbalance. Their solution was to restore the mineral foundation so the soil corrected its own acidity naturally. They weren't chasing numbers, they were rebuilding capacity. That alone makes their method worth revisiting. The power of ash begins with how it's formed. When hardwood burns at a hot, steady temperature, the organic matter disappears, leaving behind a concentrated bundle of minerals: calcium, potassium, magnesium, phosphorus, trace nutrients, and silica. These aren't vague micronutrients. They're the structural backbone of plant and microbial health. Early farmers may not have used our terms, but they understood the behaviour. They saw that ash-fed soils produced richer greens, faster root establishment, and better resilience across seasons. They also saw that plants grew well even when the soil should have been too acidic or too alkaline, according to modern standards. They didn't know the word buffering capacity, but they knew how to achieve it. The reason ash works so differently from standard pH amendments is that pH affects what nutrients are available, while minerals affect the soil's ability to hold, exchange, and supply nutrients in the first place. When you add ash, you're not just raising pH. You're rebuilding the mineral reserves that fuel microbial activity. Those microbes, in turn, regulate acidity as a natural consequence of their metabolism. In other words, the soil balances itself once the mineral toolbox is restored. This is why fresh ash-treated beds can support seedlings within days, something that would be unthinkable with lime or sulfur corrections. Using this ancient balancing trick today starts with one rule: ash must be applied lightly. The old practitioners never created piles or thick layers. They dusted it. They treated ash like seasoning, not filler. If you're working on a square metre of vegetable bed, a small handful of fine, cold, hardwood ash is enough. You should still see the soil clearly through the layer. Scratch it lightly into the surface, then water just enough to settle it. This micro-application shifts the mineral balance without spiking pH. One practical method borrowed from Scandinavian kitchen gardens involved applying tiny increments of ash repeatedly through the early season. Households collected ash from winter fires and stored it dry. When the snow began retreating in late winter, they scattered a subtle dusting over their beds every 2 weeks. This kept minerals consistently available without overwhelming the soil. It's a powerful approach for anyone growing nutrient-hungry crops like cabbage, onions, or beets. Gardeners today who try this often notice that their vegetables grow thicker skins, store longer, and resist pests better. That's the silica and potassium taking effect. Another advantage the ash masters depended on was how well ash binds to organic matter. Many modern fertilizers wash out quickly during heavy rains, particularly on sloped or sandy land. Hardwood ash behaves differently. It latches onto carbon and stays there, where roots and microbes can use it steadily. Frontier farmers in Appalachia saw this firsthand when they cleared forest patches. The ash from their burn piles nourished new fields for a full season with no added fertilizer. That same principle applies today when preparing new beds. If you're breaking new ground, scatter a thin layer of ash over the top and work it into the upper few inches. You're setting the mineral framework long before planting. One crucial part of the old method is often overlooked. Ash was rarely used alone. Early farmers always paired it with organic matter. Whether it was straw bedding, forest leaf litter, or kitchen compost, they made sure ash met carbon. This prevented over-alkalization and created the perfect environment for microbial decomposition. If you want the full effect, follow their example. When adding ash to your garden, layer it with compost or mulch. That combination is what turns ash from a simple alkaline powder into a soil restoration tool. Modern gardeners sometimes hesitate around ash due to warnings, and it's true that not all ash is safe. The ash masters always use clean hardwood ash from pure wood fires. They avoided painted wood, softwoods filled with pitch, and anything burned with trash. As long as you follow that same standard, you're using the same material that sustained European, American, and Asian agriculture for centuries. By the time you incorporate ash regularly into your soil management, something fascinating begins to happen. Your soil becomes more self-correcting. You spend less time adjusting pH and more time watching plants grow. Roots penetrate deeper. The soil becomes easier to work. Crops handle drought, pests and cold more confidently. And the obsession with numbers starts to fade because the soil is doing what it was meant to do, balance itself through mineral-driven biology. If you found this guide valuable, make sure you subscribe to Hydra Haven and share this video with someone who appreciates history-rooted growing methods. Keeping these traditions alive ensures they remain part of the toolbox for every grower who values resilient living soil.